Hello, today we're looking at Pythagoras' theorem, but this time we're going to look at some three-dimensional problems. So Pythagoras' theorem can be applied to find missing lengths inside of 3D shapes. So we can have right-angled triangles of any of the faces of a 3D shape. So in this case, I've just chosen a cube, but you could have a right-angled triangle here. You could have a right-angled triangle here. You could have a right-angled triangle here. So on any of the faces, you could find a right-angled triangle. But we can also have right-angled triangles from opposite corners of the 3D shape. So for example, this triangle here is a perfectly valid right-angled triangle, but it's going from corner of one side of the shape to the corner of the other. So this is like an internal right-angled triangle inside a 3D shape. You can even have really weird ones that look like this. Now, at first, this feels wrong. We look at this and we're like, this just feels wrong. But if we have a look, this is a straight edge. From here to here along the diagonal, that's a perfectly straight edge. So this is a right angle triangle. It's just on a really funny angle. So when you're thinking about Pythagoras' theorem in 3D shapes, you really do need to think in 3 dimensions to try and get your head around how we solve this sort of thing. Okay, let me show you how to do one of these problems. So I'm going to use the same triangle from last time. The following cube has a side length of 5 centimeters. Triangle ABC touches the internal corners of the cube. Find the length of side AB. So we know that because this is a cube, all sides are going to be the same. So if we look at this triangle here, we can see A to C is 5. I don't know what C to B is. And our goal is to find A to B, so this really long hypotenuse here. To use Pythagoras' theorem, I need 2 sides. Well, I've got A to C, that's fine, but I will need to find B to C or C to B. I need to find this side here. So that's my first goal. Well, how can I go about finding this side here? Well, if you look closely, we actually have a right-angled triangle in this situation. So because the base is 5 and the height is 5, we can use Pythagoras' theorem to find B to C to help us with our big problem. 5 squared plus 5 squared is C squared. 25 plus 25 is C squared. So 50 is C squared. The square root of 50 is 7.0711. So we can say that this length here is 7.0711. So now that we have this side here and we have the base side here, we can now do Pythagoras' theorem again to find side AB. So 5 squared plus 7.0711 squared equals C squared. This works out to 25 plus 50 equals C squared. 75 equals C squared. So I have to find the square root of 75, which is 8.66 centimeters. So the side AB is 8.66 centimeters in this 3D diagram. So whenever you have to find a side in a 3D diagram, it usually involves 2 calculations. You'll normally have to find a missing side that you don't know, and then use that answer to help you find the real side that you want to find. Alrighty, here's a question for you to give a go. For the provided rectangular prism, find the length of side AC to 2 decimal places. So you've been given a rectangular prism, you've been given 3 different sides of the prism, and your job is to follow very similar steps to the last example to try and find missing side AC. Good luck. Okay, the first thing I would do is, we know that because this side is 4, this side here has to be 4 as well. So I can just label that on my diagram. So I can see if the goal is to find AC, that means I need to work out what BC is first. Now, how can I work out what BC is? Well, we have a right angle triangle here on the floor. This little section here is a right angle triangle. So we've got a base of 8, and because this is 5, this has to be 5 as well. So we got 5 and 8, and we're trying to find the hypotenuse of this right angle triangle here. So side BC is going to be 8 squared plus 5 squared. So it's 64 plus 25, which is 89. Square root that, you'll get 9.4340. So this side here at the bottom is 9.4340. Now we can use that with the 4 centimeters at the top, and we can start finding side AC. So substitute it in. We get 105 is C squared. Square root that, 10.25 centimeters. So The missing side AC is 10.25 centimeters. Good job, everybody. Hopefully you got those questions right. So just remember, when you're doing Pythagoras in 3D, you really do need to think about all the possible dimensions when you're trying to work stuff out. And it will normally involve two Pythagoras calculations back to back. Thanks for watching.